Okay, in this video we'll do double refraction. Double refraction. We have already done refraction. We have already understood what is Snell's law of refraction, which is sine of I by sine of R is mu2 by mu1. Light is going from medium 1 to medium 2. So medium 1 is mu1 is the refractive index of medium 1, mu2 is the refractive index of medium 2, and this is angle of incidence. Let us say medium 2 is denser, so it bends towards the normal. This is R, so sin I by sin R is mu2 by mu1. Now if you have been given angle of incidence, you know the refractive index of the two mediums, you can always calculate the angle of refraction. So that was Snell's law. Now we'll do double refraction, let us say. So what are the cases in which double refraction happens, correct? So first simple example is refraction through glass slab. Refraction of light through a glass slab, correct? So that's the case of double refraction. Let's see how. So let's say this is a glass slab. Fine. Let's say a ray of light falls on this point. So this is my point of incidence. So what we do in order to see how the ray will go, first step is at the point of incidence draw the normal. Normal to what? To interface. Interface is what? Interface is the boundary separating the two different mediums. So this is air, this is glass. The boundary separating two different mediums is this. So on the point of incidence perpendicular to the interface, draw a normal perpendicular to the interface. So then if the ray will go straight, it will go like this, but since it is going from rare to dense medium, so it will bend towards normal according to law of refraction, correct? So it will go somewhat like this, although exactly how much it will bend we don't know, but it will go somewhat like this. And of course this is angle of incidence, this is angle of refraction, correct? No problem up to this point. Since the ray goes like this, now the ray falls on glass air interface. So this interface was what? Air to glass refraction. This interface is glass air interface, glass to air refraction. So again we'll do the same thing. Point of incidence, we draw the normal. Fine. So this angle is, of course it has to be R. Why? Alternate angle. See, this normal and this normal are parallel now, so these two angles will be equal. Okay, now this is going from air to glass and this is going from glass to air. So the amount by which it bends, glass to air, it will go away from the normal. And since the two mediums involved are same, the amount by which it bends towards the normal, by the same amount it will go away from the normal, correct? So how should I draw it? So it will go, finally it will come out parallel to this basically. So instead of going straight, it will go like this, correct? All right. Now if you see the original direction, correct? If this glass slab was not there, the ray would have gone like this, and since the glass slab is there, it is going in this direction, but this is still parallel to this one, because by whatever amount it goes towards the normal, by the same amount goes away from the normal, correct? So there is a lateral shift. Correct? So there is a lateral shift, means the ray, the direction of the emergent ray. This is called emergent ray. This is called incident ray. Now if I draw this direction, if I draw a parallel to this, these two directions are same. Similarly, these two directions are same. But there is a lateral shift. The ray is no more going along the line in which it is going earlier. Now it is shifted. Correct? So that's what happens, lateral shift happens, and there is no deviation. Correct? So if instead it is going straight, now it is going this way, so it got deviated by this amount. But instead also, initial direction also is this, final direction is also this. So that means if the emergent ray is going in some other direction, the angle between the incident ray and emergent ray, that is your angle of deviation. But in this case, there is no deviation. Correct? We'll understand deviation in a separate video. So this is my basic refraction through glass slab. Correct? Now what we have to also notice that the two surfaces, the two interfaces on which refraction is happening are parallel to each other. This will not be the case in prism, as we'll see. So if you remember, in prism refraction happens something like this. Correct? Something like this. Right? Remember this diagram. So air to glass, glass to air, and this interface is not parallel to this interface. These two are at an angle. Correct? So in this case, we'll have deviation. We'll see in the next diagram.